As usual, any corrections or additions will appear on screen. Hey everyone, it's July 5th, 2021, and we are at an outcrop of the Michigamme Formation. We are just a little bit north. Actually, you can see the Baraga Iron County line right there. The Net River is right over here. So we're at this outcrop on the east side of 141. Now the Michigamme itself, lithologically, isn't really something to write home about. It's pretty much a black slate. In other places, it's more of a, it's more sandy. It's more of a lithwacky, what a lot of people call gray wacky. But you'll see this white quartz, and I'll come back to that in a minute. But I want to talk about this deposit in general first. The bedding here is nearly vertical. You can kind of see it right here. It's even slightly cross-bedded, planar cross-bedded in places. But I need to tell you about how this formation came about. We know it began to be deposited about 1.85 billion with a B years ago because the Sudbury impact ejecta has been found near the base of this. Now that's smack in the middle, or close to it, of the Pinokian orogeny, which I've talked about many times before down in Wisconsin. We are north of the Niagara Fault here. So we are north of that Pembine-Wausau terrain where that ophiolite was and other things I've talked about. These are continental margin deposits. When the Pembine-Wausau terrain collided with this area, it created a little basin allowing for these deep water slates and lithwackies and stuff like that to become deposited in a four-arc basin environment. Now, when deposition stopped isn't really known, but it had to have had tectonic stresses put upon it at some point that post-date most of the Pinokian orogeny. Now, there are some granites within the Pinokian orogeny of the Pembine-Wausau terrain that date about 1.75 billion years ago. Which is after this was deposited. So there was still some sort of magmatic activity going on then. But that's where this white quartz comes in. You can see it, it's very crystalline. I mean, crystals aren't very well developed, but they're here. And you can kind of see how it's uneven, and this exists in other outcrops. And in other outcrops, it's neater and cleaner than it is here. But I wanted to stop here because I wanted to show you something. You see how the quartz kind of bends and comes around, and it comes up, and it looks like it's folded. That's because it is. Now, I already told you that this dips almost vertically here, but regionally, the Michigamme is tightly folded, even overturned in some places. And this white quartz kind of reflects that. This was discovered in the late 19th century at Baraboo, Wisconsin, to predict the Baraboo quartzite as a syncline instead of an anticline, which would later be confirmed through drilling that it was a syncline. So this type of structure, for all intents and purposes, can reflect the larger structure that was discovered, like I said, at Baraboo, Wisconsin. So this quartz would have been injected while this was getting deformed. So when was that? Well, probably around 1.75 billion with a B years ago, while this was getting compressed. Now, the Pinokian orogeny, even though it kind of stopped by then, and the Pembine-Wausau terrain was already accreted, you also had that Marshfield terrain that was yet to be accreted. That might have helped to form this. There had to be some continued compression to get this great deformation of the Michigamme here from being deposited in a deep arc basin to this undulating, highly deformed formation. So this quartz would have been deposited as hydrothermal deposits, more than likely, probably not magmatic. Slightly after this stuff was deposited, it still would have been soft, but it would have been a little after that. The quartz is deformed with the rock, so it has to predate deformation. And although the deformation of the Michigamme may have begun about 1.75 billion years ago, it may have continued up through the Wolf River event around 1.45 billion years ago, intermittently. Joints are also pretty common in this rock. So, even though we have a very unimpressive looking rock here that really doesn't have much of a use, and there are other deposits in here, there are some banded irons and some volcanics near the base as well. It's not just a simple, oh, that's boring rock, let's move on. You can still have a very complex tectonic history. But anyway, that's it. If you have any questions or comments, please leave them below, and I hope you learned something. Try to put your hands around maybe so it doesn't. Okay. Old Red Rock Road.
Red Rock.
In a 4-arc basin environment,